Welcome to my YouTube channel. Myself Halavath Ramesh. Today we will talk about a very general topic, wastewater treatment technology. So what are the technology? What are the techniques to use the wastewater treatment? So this is a very simple topic and this is very useful in engineering purpose and many purpose they are using. Even in the competitive exam also nowadays some bits are coming from the wastewater treatment technology. Now we will discuss the slide by slide what are the steps, what are the methods involved in the wastewater treatment technology. Now coming to that, before we are going to discuss about the wastewater treatment technology, we need to know first basic understanding what is water. So water is one of the abundant available substance in nature. So it is an essential constituent construction of all animals and vegetables matter, and it forms about the 75% of matter in the earth crust. So water is distributed in nature in different forms such as the rainwater, river water, spring water and mineral water. So this is the few absorption about the introduction about the water. Now coming to that source of water. You can see here source of water. Nowadays you can see these groundwater, surface water, sea water and rainwater. Nowadays is the source of water. Then you can see this slide, the main reason for the water pollution. So three main types of water pollution happening nowadays. The sewage waste and the chemical waste and the agriculture waste. These are the three major role to water pollution happening. These three types of main types for the causing of water pollution. So now you can see here the next slide, what is the water quality. So water quality, what are the parameters to drinking water quality typically fall under the three categories: physical, chemical and biological, or simply we'll call microbiological test. So in physical and chemical parameters including heavy metals, trace organic compounds and total suspended solids and turbidity. In microbiological parameters include coliform bacteria, E. coli and specific pathogenic species like bacteria such as cholera and such as Vibrio cholera and the virus and protozoan and the parasites. These we need to understand what are the water quality for the three major categories: physical, chemical and biological process. Now we can see that next slide, the indicator of water quality. So these 6 indicators are very important to analyze the water quality. So one is the turbidity, second one is the pH and third one is the dissolved oxygen, temperature, nitrates and ammonia and bioindicators. So some more clear to understand what are the analytical parameters to understand the water quality. You can see here the color, turbidity and pH and electrical conductivity, total dissolved solids, and these all the parameters. You can see total 29 parameters are available. These 29 are the analytical techniques to analyze the water quality. Okay, and you can see this picture to understand the water treatment and the recycling technology. So water treatment are mainly three categories. One, the primary water treatment technology, secondary and tertiary. Primary, you can see the screening and the sedimentation, coagulation and flocculation. This aeration, anaerobic condition. These are the some advanced technology for the tertiary water treatment technology. Okay, now you can see, understand what are the methods to analyze the water quality. So you can see the physical methods, chemical methods and biological method. So in physical method you can remove of impurities, contaminant from the water without altering the chemical composition. In the chemical methods and biological method, what you can see, go through it. You can see here also some wastewater treatment in the physical, chemical, biological. You can see physical, these are the methods to use for the physical treatment and these are the methods used for the chemical treatment water technology, and these are the biological methods to treatment of wastewater treatment technology. Now you can see the standard of good quality water. So ISI standard for the drinking water. So Indian Standard Institute, the stands for the drinking water, what are the range you need to maintain the good quality of water. So the total solids, what is the range? Less than the 500 ppm, hardness is the less than the 100 ppm and chlorides is the less than 250 ppm, iron and manganese and the arsenic, lead. And you can see these also, you can see the few 18 parameters, or the pH is 6.5 to 80 ppm. These are the 16 parameters, the range and limited they mentioned by the ISI, Indian Standard. And we can see somewhat closer to see what is physical test, and the physical and the water quality two categories, physical and chemical test. And these physical tests, like we discussed in the previous slide, the color and taste and odor and turbidity, and it can be determined. So you can see the chemical test majorly you can need to discuss about the pH. pH means nothing but of hydrogen ion concentration, hardness, dissolved oxygen. And especially biological test, B quality test is very important for the water analysis. Then the part of the sewage, what is sewage, also we need to understand this class. So the term is used to indicate the quality test from the communities, and it include the various discharge from the latrine, urine and other industrial waste comes from air. This comes under simply called as the sewage. So this sewage also analyzed by the physical and chemical methods: color, turbidity, temperature, odor, and the total solid DOD, BOD, COD and pH, chlorides and chlorides degrees. These are the sewage analysis. Now coming to that, this point is very important. So various stages of water treatment technology. You can see here, I mentioned here total 11 technologies used for the various methods to the wastewater treatment technology. First one is a screening, sedimentation, flocculation or flocculation, filtration, aeration. Sedimentation is flocculation, filtration rapid sand filtration, filtration another method is the slow sand filtration, disinfection, chlorination, activated carbon treatment. These 11 technologies, you can see these 11 are the very important for the wastewater treatment technology. Okay, so these 11 method we will go through few of the methods how to distribute this technology. Now you can see the graphical representation: raw water, you can see the coagulant and coagulation, flocculation, sedimentation, then filtration, disinfectant like chlorination we will add here, and treatment of water and storage, then distribution to the home consumption. This is the rough diagram about the water treatment technology for the analysis of water treatment. Now coming to that, first one step is the screening. So what is screening? Screening means nothing but of already see here the picture, you can understand the nothing but of it is called as the holding or the large size of any undissolved suspended particles. You will be stopped or removed from the screening technology. Now going to that method of aeration. So aeration also is one of the best water treatment technology. This is simply called as the removal of gases, either carbon dioxide if it is there in water, it should be removed, and methane, other gases should be removed by the aeration technology. Now coming to the next method is a sedimentation. Sedimentation, what is the main concept? To settle down the bottom of the undissolved suspended particle. Suppose if you have the stone in your water, the stone should be settled down, the upper water should be transport. So that is called as sedimentation. Okay, so sedimentation means it will be settled down the bottom of the waters, any liquid form. Then you can go for the coagulation. Coagulation is the destabilization of colloids, kind of addition of chemicals to neutralize the negative charges. Okay, so this is somewhat the chemical process. This one simply coagulation is the chemical process. To know, coagulant usually higher valency electron cations like aluminum and iron, etc. Coagulation is essential for the chemical process. Rapid mixing of required to disperse the coagulant throughout the liquid. So you can see charge neutralization, how it is happening here. This picture to understand this, how this flowing, and continuously the mixing of this coagulation method. Now you can see for next one is the filtration. So the process of passing the water through the beds of the such granular materials known as the filtration. So already we discussed about the earlier slides. Filtration, again the two types. You see the types of filtration: slow sand gravity filtration, rapid sand gravity filtration. You can see these inlet and outlet, how under drains and the gravels and sand. This is the one of the methods to apply the pressure to filter the water. Okay, then what is the next method? You can say disinfection of the water. So this is also one of the very important techniques to analyze the water or to treatment of the water. So disinfectants mean nothing but a removal of harmful bacteria, right? Pathogenic bacteria. So that is, you can go through this main concept, and you can removal of bacteria. This comes under the disinfectant biological process. And next one come under the ozonolysis. Ozonization of water treatment. So ozone is the molecule composed in the three oxygen atoms temporarily exist in very unstable and reactive state. So ozone is very strong disinfectant and oxidizer. You can see here the ozone removal of hydrogen sulfide, manganese, iron and bacteria and virus. So any pathogenic contaminant that can be disinfected, altered or removed through the oxidation process will be affected by the ozone. So that is the call of the ozonization. So the oxidized properties of ozone can reduce the concentration of iron, manganese, sulfur and help to eliminate a taste or the odor problems. So this is called as the one of the best method for the water treatment technology, ozonization. Then we can come into that somewhat advanced UV water treatment technology. So passing of UV lights to kill the what are the microbes present in the water. You can see this typically UV disinfection system involved in the flow of water through the vessels containing UV lamp. So what happens in this water passing through these vessels and the microorganisms are exposed to the intense ultraviolet light energy which cause the damage to genetic molecules like nucleic acid, DNA and RNA need to reproductive functions. So what happens when you expose to that water UV light? So what happens, the UV light will fall onto that very bacteria, any biological living things, microorganisms simply called, they have the genetic materials like DNA, RNA, nucleotides. So these can be destroyed and it will be killed. There is no needs to the reproductive functions. So this is the method we will call as a UV ultrasound water purification technology. Okay, now you can see this here. What is chlorination? This is also very important. Water disinfection by the chlorination was first used in the 908 by Jersey City in USA. Chlorination is the greenish yellow toxic gas found in nature only in the combined state, cheaply with the sodium and carbon salt. So the reaction of chlorine in water, chlorination is the unusually accepted method of disinfection. So chlorine gets distracted or removal of the bacteria. That point is very important. Normal the chlorine dosage or the chlorine is recommended by the 2 mg per liter. So how much chlorine gas is need to required means 2 mg is required for the to purify the 1 liter of water. So that point we need to keep in mind. Some competitive exam they will ask you. Then you can see what is that somewhat more advanced about the chlorination. So water become chlorinated must be free from turbidity and chlorine demand of water should be estimated. Contact periods of 1 hour of essential to kill the bacteria and virus and minimum recommended concentration for the free chlorine of 0.5 mg per liter. Okay, why the chlorination? Chlorine is widely used to effective to low concentration and cheap and form a residue if applied in sufficient dosage. So chlorine is applied for la gas like Cl2 or hypochlorite bleaching powder CaOCl2, right? Twice CaOCl2 twice. So this is a bleaching powder formula. Simply village people they are used. And next one can see this breaking point of chlorination curve. Sometimes the competitive exams and the advanced they will ask you. You can see the chlorine residual mg per liter and this is you can chlorine added mg per liter. You can see the chlorine demand and the combined residual and destruction of the chlorine. This is called as a break point, right? And the free residual and free residue. So break point of chlorination curve also is very important. You can see here 1, 2, 3, 4 steps. And after third step, we need to go for the chlorine added 8. So this is called as the break point. So sometimes they will ask in exam what is the break point. So the hope you will understand about the today lecture, the wastewater treatment technology in briefly, and the next video we will discuss about very detailed about the each and every techniques. Suppose if we say what is sedimentation, what is chlorination, what is decantation, this we will discuss about very clearly, and we will update soon for more information about the wastewater treatment technology. If you like this video, please like, share and subscribe my YouTube channel.